Everyone, welcome back to the DSA solutions. Today we'll discuss how to construct a binary search tree from Preorder Traversal. Let's break down the process of constructing binary search tree from a given Preorder Traversal array with one example. So the Preorder Traversal we have 5314869. We'll construct binary search tree step by step, ensuring that at each step the binary search tree properties are maintained. In binary search tree construction from preorder traversal, we start with the root node because preorder traversal always present the root node first, followed by the left subtree, then right subtree. And this sequence allows us to construct the tree in same order. It was traversed. Root first, then left, then right. We pass the preorder array and set the boundary to the construct BST method. So from the array we take the first element and create the root node with the value 5. Now we'll focus on creating the left subtree of 5. So we call construct BST with the next element 3 from the preorder array and the boundary 5, and which is the root node value. Since 3 is less than 5, it qualifies to be in the left subtree of root node. So we create a node with value 3 and set it as the left child of root. Next, we'll focus on creating the left subtree of node 3. So we call construct BST with the next element 1 from preorder array and the boundary is 3. Since 1 is less than 3 and it qualifies to be in the left subtree of node 3. Now we'll focus on creating the left subtree of 1. So we call construct BST with next element 4 from the preorder array and boundary is 1. Since 4 is not less than 1 and it not qualify to be in the left subtree of node 1, so we set left as null for node 1. Now we'll focus on creating the right subtree of node 1. The boundary of right subtree of node 1 is determined by the nearest ancestor node that has a value greater than 1, which is 3. So we'll call construct BST with the next element 4 from the preorder array and the boundary is 3. Since 4 is greater than 3 and it not qualify to be in the right subtree of the node 1. So we set right as null for node 1. Now we'll focus on creating the right subtree of 3. The boundary for right subtree of node 3 is determined by the nearest ancestor node that has a value greater than 3, which is 5. So we call construct BST with the next element 4 from the preorder array and the boundary is 5. Since 4 is lesser than 5 and it qualify to be in the right subtree of node 3, so we create a node with value 4 and set it as the right child of node 3. Now we'll focus on creating the right subtree of node 5. The boundary for the right subtree of node 5 is integer max value, and it ensures that all element we can pass in right of 5 is greater than 5 but within the range of integer max value. We call construct BST with the next element 8 from preorder array and the boundary is max. Since 8 is greater than 5, so it qualifies to be in the right subtree of node 5. So create a node with a value 8 and set it as the right child of node 5. Now we will focus on creating the left subtree of 8. We will construct binary search tree with the next element 6 from preorder array and the boundary is 8. Since 6 is lesser than 8 and it qualifies to be in the left subtree of node 8, so we will create a node with value 6 and set it as a left child of node 8. Now we'll focus on creating left subtree of 6. We call a construct BST with the next element 9 from the preorder array and the boundary is 6. Since 9 is less than 6 and it not qualify to be in the left subtree of node 6, so we set left as null for node 6. Now we'll focus on creating right subtree of node 6. The boundary for the right subtree of node 6 is determined by the nearest ancestor node that has a value greater than 6, which is 8. So we call construct BST with next element 9 from the preorder array and boundary is 8. Since 9 is greater than 8 and it not qualify to be in the right subtree of node 6, so we set right as null for node 6. Now we will focus on creating the right subtree of node 8. The boundary for right subtree of node 8 is integer max value. It ensures that all element we can place in right of 8 is greater than 8 but within the range of integer max value. So we call construct binary search tree with next element 9 from preorder array and the boundary is max. Since 9 is greater than 8, it qualifies to be in the right subtree of node 8. So we create a node with value 9 and set it as a right child of node 8. Now we don't have any more element in our preorder array. So this is the binary search tree we have constructed. To the coding part, this index is assigned to 0. This variable used to track the current element index in the preorder array. So for each recursive call, we'll check if index is beyond the array length or if the current element is greater than the boundary for left subtree or less than the boundary for right subtree. If either condition is true, we return null, indicating that absence of subtree. Otherwise, we create a new node with the current element and increment the index. Once a node is created, we recursively call the same function to create the left and right children. Construct BST method take the preorder array and a boundary as an argument, then index variable that keeps track of the current position in the preorder array. This method will check the boundary. If the element is within the boundary, then we'll create a node and we'll assign this to left or right child as per condition.